Good evening. Tonight we're going to talk about normalization of database tables. Database design analysis is a technique used to improve a data model for implementation as a database. The goal is a simple, non-redundant, flexible, and adaptable database. Normalization is a data analysis technique that organizes data into groups to form non-redundant, stable, flexible, and adaptable tables in a database. So today we're going to go over normalization and talk about the three normal forms. So we've discussed several times this semester the nature of the relational model. Data is organized into tables, and a set of attributes and a number of entities with those attributes are in each table. We have a strict record format. Every record has the same fields, and there are no duplicates. We also discussed organizing tables into themes. Each table is about an entity, not about multiple entities. An entity is a thing defined by one theme: student, instructor, department. We get problems when we have a universal table with all fields. So take this one, for example. What are some of the problems we see here? Well, duplicate data. Also, modification anomalies. If we delete Mozart, we lose all information about the music department as well, and we may not want that. So what if a computer science department, for example, changes from Taylor to Hrabowski? We have to change it in multiple places, not one place. And what if we miss some? Then we have inconsistent data. So we need to consider breaking our universal table into a set of tables that are organized better so we can avoid these type of problems with our design. ER diagrams are one approach and a good start. They are more for the conceptual design, the one that we show the customer. Well, so how do we go about analyzing each table we have from our entity relationship process? That is called normalization. Determination is some non-key fields may determine some of the other fields in the table, and that is an indication we don't have a good design, that we have multiple themes in our table. Notice that in the previous slide, department determines building and budget, even though the key for the table is instructor ID. So although instructor ID determines all other fields, a non-key attribute, which is department name, also determines a subset of the fields. And this indicates that there are embedded themes in the table. And our approach to correct this problem is to decompose. So first normal form is an entity whose attributes have no more than one value for a single instance of that entity. Any attributes that can have multiple values actually describe a separate entity, possibly an entity and a relationship. Second normal form is an entity whose non-primary key attributes are dependent on the full primary key. Any non-key attributes depend on that depend on only one part of the primary key should be moved to an entity where that partial key is the full key. And this may require creating a new entity and relationship on the model. And finally, third normal form is an entity whose non-primary key attributes are not dependent on any other non-key attributes. Any non-key attributes that are dependent on another non-key attribute must be moved or deleted. Again, new entries and relationships may have to be added to the data model. And we can remember these three forms by saying that all non-key attributes in a table must be dependent on the key, the whole key, and nothing but the key. So normal forms are guidelines for designing relational databases that are expressed in our text with a formal syntax and mathematical rigor. The process of decomposing a database design into one of the normal forms is called normalization. By normalizing a database design, you will avoid update, delete, insert anomalies. You'll avoid redundant data and data inconsistencies. The process of normalization will result in more tables than would be present in an unnormalized design. This might favor updates because the tables would have fewer columns, but it will certainly penalize retrievals. To retrieve the complete data that we might want will require the joining together of several smaller tables, and that will result in poorer performance. Odd developed the normal form guidelines on the presumption that all non-key fields will be updated frequently. This is not true in data warehouse systems, however. So they use a different schema rather than a normalized schema. They use what is known as a dimensional schema. CODS normalization is relevant, however, to transactional databases. So here's how we go about the normalization process. We work on one table at a time. We identify the dependencies of the non-key attributes. In other words, are they determined by some fields in the table other than the non-key? If they are, then we will decompose those that table into two separate tables. One table has the set of fields that are dependent on a non-key attribute. That determinant becomes the primary key of the new table. And then we have a foreign key relationship between the original table and that one. And here's the various normal forms. One thing to keep in mind is that in most corporate databases, they will go up through the third normal form. And sometimes when they reach the third normal form, they may back off to a lower form in order to improve performance. So again, we can summarize functional dependencies in a slogan. Every non-key attribute is dependent on the key, the whole key, and nothing but the key. If this is not true, then a non-key attribute determines a subset of fields in the table. So partial dependency violates second normal form. Every non-key attribute is dependent on the whole key. Transitive dependency violates third normal form. every non-key attribute is dependent on nothing but the key. Let's take a look at some examples of violating the normal forms. So normalizing to first normal form is essentially making your design relational. Every row is in a table must have the same number of fields. Furthermore, there can't be any repeating fields or groups, things like a phone number that has multiple values. So each attribute value must be a single value. Additionally, the domain of an attribute must be atomic. And finally, no two rows can be identical, so there has to be a key that uniquely identifies each row in a table. A design must be in first normal form as a starting point to transition to second normal form. So we are starting with single valued attributes. Second normal form places restrictions on the relationships between key fields and non-key fields in a table. In second normal form, each non-key attribute is a fact about the key and must be about the whole key. In other words, a fact from a non-key attribute cannot be a subset of the key, a part of the key. So let's look here. We have a key that is composed of two attributes. And they are part number and warehouse number. So if we look at warehouse address, it's redundant. What if the address of a warehouse changes? We have to change things. Data might become inconsistency. There's no place to keep a warehouse address, or the warehouse for that matter, if there's no parts in a warehouse. Now, warehouse address is dependent on only part of the key. And that part is warehouse number. Doesn't depend at all on the part number. So this violates second normal form. Each non-key attribute, like warehouse address, must be completely determined by the whole key, part number and warehouse number together. It cannot be determined by part of a composite key. So of course, we have problems with this. Warehouse address is determined only by warehouse and not by part. So that's a partial key dependency, and it violates second normal form. So this design is in second normal form, and it enhances data quality by reducing redundancy and update anomalies. So we took the offending field and its determinant out, made it a new table, and then we have a key from the parts table to the new table so we can join and get the complete set of information. Now, there is no free lunch because that join increases our retrieval time. We must join the tables to get all the information, and that is costly. However, with the bad design, we would get all the information without the cost of a join. However, we do run into those update anomalies. If we get rid of all the parts in a warehouse, we lose information about the warehouse as well. A design must be in second normal form as a starting point to transition into third normal form. So we're talking about single valued attributes, and every non-key attribute is a fact about the key and must be about the whole key. Third normal form adds and nothing but the key to that oath. So let's say a campus's city is determined by the campus. In other words, there's only one campus per city. So in this particular case, we see that a campus's city is repeated for every employee assigned to that campus. If a campus city changes, all records that have that duplicated city must be changed. With redundancy, there's a risk that some data may become inconsistent with different records showing different cities for the same campus. So if we look at this relation, the non-key attribute city is also a fact or determined by another non-key attribute campus. In our normalization process, we identify this determinant. Then we will decompose, if there is a determinant like this, campus determines city and campus is not a key. Then we decompose the table into two tables, the employee table and the campus table might be a good choice. So our normalization process is we identify the key, test the table against each normal form rules. If it fails to satisfy a normal form, then we split the relation into two new relations. And we continue this until it does satisfy the normal form we're driving for. And as I mentioned, typically in business, that's third normal form. So obviously we mentioned we want to eliminate repeating groups and put them into a separate table with their own key. And we'll have a dependency diagram we can create, and that's just going to show what non-key attribute, well, what fields in general determine the value of other fields. And then converting to first normal form, all attributes are dependent on the primary key. There is a primary key for each row in, or each record in the table, each row in the table, and there's no repeating groups. So here we can see a dependency diagram. We have a composite key, project number, and employee number. Project name is partially dependent, so that violates second normal form. Employee name is partially dependent on employee number. Charge hours is dependent on job class, which is a transitive dependency. So we see we've got a dependency diagram that lists the determinants. So obviously project number and employee number uniquely determine all the other values. However, project number will also, part of the key will determine project name. Employee number will, again, part of the key determines employee name, job class, and charge hours. And then transitive dependency job class determines the charge hours. So there's some problems in that table. So we want to decompose that table to eliminate partial dependencies. And then obviously reassign the dependent attributes to the appropriate table. So the table is in second normal form when it's first, it starts in first normal form, and we eliminate all partial dependencies. So here's the result of us putting the table into second normal form. We've taken out project, we now have a project table, and we have an employee table. And we have our original table that's now called assignment. We've got the project number and employee number and the assigned hours. Notice we still have a problem in our overall database in that the employee table has a transitive dependency. So to convert it to third normal form, we make sure it's in first normal form, and then we decompose any transitive dependencies into a separate table. So now we're in third normal form, and we've gotten rid of the transitive dependency. Job class becomes a new table. So again, when we're looking at our requirements for a good normalized set of tables, every non-key attribute is about the key, the whole key, and nothing but the key. So then we can start adding values into our records. As we see here, we put project information in, we put job information in, then we have our completed database assignments, and then the employee. So one thing we want to consider is this idea of what should our primary key be? Now, we mentioned that a primary key is a candidate key, and that is it's a key, it's a set of attributes that uniquely determine a record in a table, and it's minimal. We can't reduce it any farther. Additionally, we said we want maybe a good business reason to use a particular key. So for example, we might not use Social Security number in the instructor table to minimize the risk of identity theft. Well, we can even do better than that. We can say, let the database create a surrogate key for us. And this is where the database, all these database systems know how to do this. They will create a numeric key for each record that is guaranteed to be unique. And so you eliminate any problems with things like identity theft and so on. So again, normalization should be part of the design process. First steps, you're going to go out, do your requirements analysis with your users. You're going to come up with an entity relationship diagram that you can communicate with your users. You'll get a refined version of your database design. And once you have that refined version and the users like it, then you can start looking at doing normalization. Obviously, this is going to be an iterative process. So here we have, perhaps an initial entity relationship diagram, employee and project. And then we're going to take jobs and have a job code added for our employees, because right now we've got job description and job charge hours, but obviously that is a transitive dependency, so we want to get rid of that in our employee table. Then we have project as a many-to-many type relationship. One employee is assigned to many projects, and one project may have many employees assigned to it. Here we have in the place of that a junction table assignment that instead of having a many-to-many has two one-to-many relationships. And we discussed the need for doing this because relational databases don't have a mechanism for a direct many-to-many. So we decompose them into two separate one-to-manys and put a junction table or some other, it goes by many names, but the idea is it's a table that implements a join between the many-to-many tables. And then we have our implemented database with values in the fields. I've mentioned several times in the lecture so far, there's no free lunch. When you decompose your table in the normalization process, you're going to increase the performance requirements when you do retrievals because you have to join tables together, and that's a relatively expensive operation. That's going to reduce the system speed. So oftentimes in a corporate database, obviously in the world of computer science, they only care about purity. In the business world, we care about reality, and we have performance guidelines that we have to meet. And so sometimes we'll take a database design up to third normal form. And as we have it implemented and we start getting data on it, we find that we're slowing down because of certain joins. At that point, we back off, we put the two decomposed tables back together as a single table, even though that violates our normal forms. And we do that for the sake of performance. Okay, so checklist for our database is we want to properly document all the business rules. That's the requirements we gather. Make sure that they're written precisely, clearly, and simply. And those requirements are going to identify the entities, the attributes of each entity, the relationships between entities, and business constraints. So an entity might be instructor, the attributes might be the instructor ID, name, department, and salary. Relationships might be that an instructor teaches the relationship classes, and an instructor is member of relationship department. Constraint might be salary has to be between $20,000 and $100,000. And of course, we, as good requirements analysts, we identify the source of all business rules and that the business rule is justified, dated, and signed off. We should have a good naming convention. We don't want to have extremely long names. Names for our tables should be nouns familiar to the business, short and meaningful. Attributes should be unique within a table. And we should use the entity abbreviation as a prefix. And relationship names should be active or passive verbs to indicate the nature of the relationship. Each entity should represent a single theme or a single subject. We don't want a table composed of instructor department. We want one table with instructor, another table with department. Obviously, that's, again, in an ideal world. If we run into performance issues, then we might go into an unideal situation, or less than ideal situation. And again, attributes should be single valued, not multi-valued. So if we have a phone, we're going to take multiple phone numbers out of the student table and create a second table called student phones. We want to watch out for derived attributes, and non-key attributes must be fully dependent on the primary key, as we've discussed. All non-key attributes depend on the key, the whole key, and nothing but the key. And the relationships should show cardinality and clearly identify the participants in the relationship. Okay, any questions?